we'll go ahead and get started. I'm really excited to share some fun and interesting ray tracing details with you guys today. So my name is Lydia. I am a partner marketing manager at Unity. I helped bring together NVIDIA and some of our amazing Unity insiders to talk about their projects today. We also have Elena joining us from the technical marketing team. And first off, I'll introduce Richard. Richard is the ray tracing evangelist at NVIDIA, specializing in game engines. We also have Ruben, also known as the game dev guru. He runs a blog that focuses on Unity game performance. And then we have Emil, who professionally creates commercial M&E projects located in Unity's home country of Denmark. So we'll just go ahead and get straight into some Q&A. We polled the community in advance of this, and you guys were really interested to know how to set up a ray traced scene in Unity. So a lot of what Ruben and Emil will go through today are going to be basically how to do that, showing examples from Emil's project. Ruben will walk through some of the kind of foundational steps as well. And then Richard, of course, here working at NVIDIA, the powerhouse that brings you the GPUs that make this all possible, will be able to talk a little bit about ray tracing in general. So actually, Richard, why don't we just start off with you? Just let us know, what is ray tracing? How is it different or better than kind of what came before it?
Yeah, so I think when talking about ray tracing, it's helpful to understand that the old techniques like raster rendering. This is a raster describes a collection of rendering methods we've used for like the past 30 plus years to get images to the screen. So it's a myriad of hodgepodge different ways to blitz stuff to your display. I think you could say in general, raster rendering it's fast and flexible, but what it lacks is accuracy. And what ray tracing is looking to solve is how can we do graphics more accurately and better than the old rendering methods. So, for example, maybe if you're a developer, you've used modern screen space effects like screen space AO or screen space reflections. You know that if you use screen space reflections, you know that like it looks fine maybe at a distance. You know, it's kind of blurry. It's not exactly, a mirror reflection, but it's there and it's dynamic. But when you get up close to it, it kind of falls apart. So ray tracing, seeks to solve problems like that. Ray tracing is different than raster rendering in that it's physically accurate by tracing rays of light. So light rays are fired from the camera into the scene in order to sample pixels for their accurate color. So yeah, this sort of sampling is a lot more, a higher degree of accuracy. It doesn't suffer from the shortcomings of screen space effects. And it allows us to do things we couldn't do before, like accurate reflections. It's important to understand too that rasterization is not completely abandoned with ray tracing. It's a part of the mix. Ray tracing is solving particular aspects of rendering. So, improved shadows, improved reflections, improved translucency, global illumination. But there's still lots of things that rasterization does. It handles material shader techniques. It handles non-shadow casting lights, for example. So really you can look at ray tracing today as a hybrid model. It's a hybrid between rasterization and ray tracing. Ray tracing is used to get accuracy in certain details, and rasterization is still used for everything else. From NVIDIA's standpoint, the exciting thing about ray tracing is that it opens the door to all kinds of new rendering methods and techniques and powerful ways of putting the scene together that we couldn't do before. We've been kind of in a step one phase right now where we're improving accuracy. We're trying to get performance better. We're trying to improve certain aspects of it. But down the road, it has a lot of growth. It will eventually be able to do things that like we never could have done with raster rendering alone, and that's why it's important to the future of rendering.
Wow, it's incredible. So this is really, future facing and future proofing the
Yes.
visualization that we're seeing in games, even in non-games, right? Of course, there's plenty of commercial projects that use real-time engines, and it's pretty interesting to see all the different use cases that ray tracing comes into play. So Ruben, also known as the game dev guru, you actually created an in-depth series of blog posts that really got into the nuts and bolts of ray tracing in Unity. So I'd love to hear from you, like, just what does ray tracing actually mean to you? And were you really surprised or impressed by anything as you got into it?
All right, so let me share you a little backstory on why I got really into ray tracing. So when I started seeing all this marketing material from NVIDIA, I was really blown out, right? Especially to hear that it was real time, right? I've been used to seeing these old movies, of course, rendered offline and they look fine, but to see this in real time and also for me to have the chance to play with this sounded like quite exciting to me. Nevertheless, when I was looking at these materials, I often saw these comparisons like left to right or ray tracing off to on. And I thought I was a weirdo, honestly speaking, because sometimes it took me like 5 minutes to really spot the differences, right, between left and right. And I mean, it was not always the case because for some effects like reflections, it was pretty obvious. And yeah, but for other effects, I spot, I took like 5 minutes just to see the differences. It reminded me of all these games like the Spot the 5 differences, right, where you have to start. Here's the difference. Actually, let me show you the screen. So this is what I'm talking about. For example, you can see the differences, right? But sometimes they are subtle. And even if you think about it, they can make a huge difference. Like your brain knows it. You just don't know it. But, sometimes it's really hard to see these differences. So I thought it was a weirdo, but then I saw some other people having these issues as well. And they were wondering, hey, what's actually the difference here? At least for the more subtle effects. And this is what inspired me to create these blog posts, where I really put a strong focus on letting people control the amount of ray tracing between two images, right? Instead of doing side by side, what I did is to do something like this, like you're seeing on the screen. Let me zoom in a bit, where I give you control over the ray tracing functionalities through a slider, okay? So for example, this is the comparison between screen space reflections, like raster base, and also to the right, if I scroll to the right, you will see subtle differences going into ray trace reflections. You probably don't see it very strongly, depending on the quality of the streaming, but I have more effects here in my blog post. For example, in the global illumination one, is super obvious. So here is without global illumination. So we are lacking a lot of these bounces. And as soon as I start going to the right, I start seeing the overall brightness going a bit up.
Beautiful. It really helps to illustrate the point when you can see that slider and the subtle effects change. And then you realize how sort of almost two-dimensional it looked before.
Yeah, I agree. And also for random occlusion, and there's a ton more of effects here. So for me, it worked like this. When I first understood what ray tracing did, like visually speaking, only then I got motivated to start learning the technical reasons behind this, right? For me, it comes understanding and then the motivation to learn about all of this. And I actually did this blog post and people were really happy about it. So I'm really happy with the results here. You also have context shadows and quite a lot of these things. One of the things that really surprised me from the HDRP pipeline, I didn't really know this until I started playing with it, is the debugging functionalities that it has. And it is actually not so much about debugging, right? It is also about understanding. For example, I prepared a screenshot here. So if you use the HDRP pipeline, then you have a debug screen here on the bottom that lets you, instead of seeing the final frame buffer, you can also select to see the contribution of specific effects to the scene. And this helped me a lot understanding how graphics worked. In this case, I'm just rendering the contribution of global illumination to the scene. It is something that you actually paint on top of your scene. So by seeing these individual contributions, then I was really able to understand a lot of the internals of rendering and how it's supposed to help me. So this is one of the things that, I was totally surprised by with the HDRP pipeline.
That's fantastic. And, thank you also for bringing up HDRP. I think that it's worth mentioning, of course, that ray tracing is a component of Unity's high definition render pipeline. Currently, ray tracing is still in preview. So for the latest version of ray tracing in Unity, please go ahead and check out Unity 2020.2 beta, because that will be able to have the latest, greatest features. And I think that everybody here has been working on that version for their projects. Actually, Emil, why don't we go to you? You actually created a really incredible ray trace scene in Unity from scratch. It's completely beautiful. I think we should definitely show folks here on the screen what this project looks like. Please, I would love if you could share some more about your experience setting up this scene and your experience using ray tracing in Unity.
Yeah, sure. And thank you for the nice words. So this scene, as you can see here, is a scene created in Unity's HDRP. And my creative process was really influenced by ray tracing in how quickly I could get pretty good results in terms of fidelity. Because I might be able to achieve something like this with big lighting and setting up light probes and like really iterating on the quality. But for me, it was pretty amazing to create a new project, go through the wizard to install the ray tracing, set up a global volume, and pretty much tick on, in my case, path tracing, and out of the box have pretty amazing results. So as you can see, my scene is not particularly heavy on reflections or subsurface scattering or anything like that. It's pretty much diffuse lighting, which I guess could be achieved in without ray tracing. But for my creative process, it was just amazing to this quickly get into seeing instant results. I think that's the nice integration between real-time engines and ray tracing, because that's pretty much the purpose, to quickly see the final result. And ray tracing is just a huge step in that direction. And that gave me a creator's high, and also opened up time and creative energy to work on the scene and not work on volumes and baking light maps and stuff like that.
Fantastic. And now, you guys who are tuning in, this actually is streaming, of course, over Zoom. So you might be seeing a little bit of a slow frame rate, but we can assure you that this is very performant on the actual machine. And I think also, Emil, this is set up on a virtual machine as well.
Exactly. So this is both streaming over Zoom and streaming to another computer located in Copenhagen. That's why you might see some more sluggish results. But from my perspective and working on this scene, I think I got around between 30 and 50 frames per second. And even the noise, even you can see it when I rotate it here in the editor, is the scene view. It wasn't really an obstacle. It takes like 1.5 seconds, and then it's pretty clear. So from an artist point of view, it was really amazing to work in.
Can I actually ask you a little bit, and this might be a little bit off topic for the conversation, but I'm so curious about these characters and their incredible design. The colors are beautiful. It really, really shines in this stark white background. Where did these guys come from?
For this exact piece, they were imported from Adobe's service called Mixamo. And they're actually free of charge for both personal and commercial use. So to quickly get a project running, I simply imported them, and they got an integration with Unity. So it takes like a one click, and it's imported with animations as well. So you can apply walk animations, or in this particular instance, I took like a jump attack animation, and then I froze them at a particular point in that animation. And they look kind of different in the original Mixamo version, but I want to give them this exact kind of glowing, popping look. So I created a custom shader in Shader Graph. As you can see here in the right side, I exposed some of the properties, brightness, for instance, so you can make them really pop and really glowing. And this kind of gradient shader, which enables me to change the color and stuff like that, while retaining some of the work that was done on the mixed mode characters in terms of textures. So that was quickly importing some characters and then customizing them in Unity's shader graph.
Incredible, beautiful colors. Is there anything else about this project that was a challenge you had to overcome, or something that maybe was a little bit unpredictable or complex?
So the first thing I did was to quickly make a vertical slice of the scene. So I want to make sure that everything I had in mind was actually doable. So at first I wanted to do like a waterfall behind them, but as far as I know, VFX Graph is not really compatible with ray tracing yet. Hopefully it will be at some point. So that kind of made me change the environment to something more resembling what we see here. So it's important for me to quickly get the characters in, get these kind of assets in, and see what was compatible and what was not. And it's important this is for a graphical demo. If you want to do it for like an animation project or for a game, you should really import your different aspects of the scene and be sure that it's compatible. Because I know stuff like terrain and LODs isn't really supported yet either. So that was my process, quickly seeing if everything worked, and then try to adapt the scene to fit a ray tracing environment.
Yeah, if I could ask a Bila question, what ray tracing effects did you decide on for this scene exactly? It looks like ray trace shadows, but anything else, or?
So this is actually using a path tracing, as you can see here in the right-hand side. So from what I understand, I'm not a technical person per se, but I understand that path tracing takes over. It kind of replaces all other ray tracing effects.
Yeah, it's the ultimate ray tracing, basically. The ultimate.
Exactly. Yeah, and that was perfect for my project, because it's a graphical demo, and the performance was good enough for this purpose.
Yeah, that's great.
And it also had the upside of, like I said, quickly turning on one single thing in the volume, and then I'm pretty much ready. So at a later stage, I could go and, like you can see here, I'm increasing the maximum depth, and so I got even more bounces.
Yeah, I was going to say, with those really colorful plumes, it looks like you have some GI going on in there, but I wasn't sure if that's what I was seeing or not.
Yeah, that's pretty much just one bounce, because I only realized at a later stage that I could have gone and increased the maximum depth, but then I had to compensate in other parts of the exposure, because this is overexposed, at least to my intentions with the scene. So I just went with one minimum bounce and two maximum, and that fit my purpose just fine.
So is there anything else, Emil, that you wanted to surface or highlight about working with this project in particular, or anything you wanted to share about what comes next for it, if there's more things you're excited to do, or expanding it in additional ways?
The main thing is, of course, reflections and subsurface scattering and stuff like that, and I'm totally gonna take the Titan card and test what I can do with it. But as I've emphasized in this rundown, for me it's getting started this quickly. I think that's a major selling point for me, because it opens up so many different ideas that I can do in a day or two. So this scene was pretty much created in 2 days, and that's just I can't really grasp how many projects I can actually realize when it's pretty much turning on ray tracing like this. Then there are some technical aspects. Like, it took me a lot of time to realize that you had to enable always refresh up here in the camera view, and small stuff like that. That's really important to get. You can pretty much, I'm sure you can read Ruben's post and you're good to go. Just whenever those are ticked off, it's just amazing to get started this quickly.
Great to hear. So let's switch over, actually, speaking of Ruben. So one of the most, like I mentioned earlier when we first kicked off this session, was that one of the most common questions we got from our community was just, how do you set up a ray trace scene in Unity with HDRP? Can you take us through a few key steps that you took to set up your ray trace scenes and kind of how you covered it in your blog?
I definitely can do that. Let me share my screen. This morning, I put together a very quick blog post on how to get started with ray tracing. Now, I am not an expert on ray tracing, so that means that this is just one way you can do this, but there are multiple ways, right? So in my experience, what it helps is to use the Unity Hub. By the way, this is one of the assets that I got from a colleague of mine called Jens. I think it's pretty amazing. Looks very, very awesome. If you want to have some details on that, there's a link below. Feel free to have a look. But yeah, I will show you right now how it actually looks at the end. Okay, so the first step that I recommend everyone do is to, of course, use the Unity Hub. Once you have it installed, and I guess you already have it installed, what I suggest is to use one of the latest Unity versions. For example, the 2020.2, especially the beta ones. The Unity team has done a lot of improvements when it comes to ray tracing in the latest versions. So I think that's the reason that you should go for this version. So like the video shows, pretty straightforward. Just take the latest version and give it the name you want. Now, I recommend starting with the original 3D template. That means the built-in renderer. Mostly because if you start with the HDRP template, it's going to take a bit longer because of the data that comes with. But this is also another way that is totally doable. Okay, so once you created your project, you need to import, let me put this full screen. You need to import the HDRP package. You probably know how to open the package manager, but actually I'm going to stop and pause the video from time to time. I don't know how fast the streaming will go. So you need to go to Window, Package Manager, and from there you can look for high definition RP. And there you go. I advise you to use 10.2.0 onwards, because again, Unity has done great improvements on ray tracing from this version onwards. So basically, you just need to select it and then click on install on the bottom right. Then you just have to wait a few minutes. I cut the video for you so you don't get bored. And once HDRP is imported, then a very useful wizard will pop up here. And this is going to make 90% or 95% of the work for you. Once you have this pop up here, what you need to do is to set it up, set the pipeline up for HDRP plus DXR. So you open this tab, and then it will give you 1,000 errors. But that's fine, because Unity took the liberty of adding a fix all button, which is pretty handy. So you click it there, and then after a few seconds or minutes, depending on how fast the computer is, HDRP will ask you if you want to create or load all these assets and resources that the HDRP pipeline requires. I think the easiest way is to just click on create one. That way you don't really have to bother with importing new things. After that, grab a quick coffee, a few minutes. And finally, this is one of the last steps. Unity will ask you to restart the editor. And the reason for this is that Unity switches to DirectX 12. I think by default, Unity is at 11, but for ray tracing, you need to switch to DirectX 12. This is only one thing that you have to do once. So just go ahead and click on Restart Editor. So by then, if you manage to do all this so far, then you have a project that has that is basically ray tracing enabled. So you go ahead after that and create your scene the way you want. You can, of course, start with a plane and a few cubes, and everyone starts like that. What you need to do later on when you're finished creating your scene is to decide which ray tracing effects you want to activate. Or in other words, which ray tracing effects you want to add support to. You do this by going to the project settings. You go to edit and then project settings, and then in the HDRP tab on the left, you will see all of these settings. There are a million of them. You don't have to worry about all of them. What I suggest you to do is to use the filter, the very handy filter that is on the top right, that says, well, that is for searching, right? And you can type in here screen space. So once you do this, you will see a lot of these options that you can enable or disable based on the effects that you want to put in. Now, if you're just playing around, I think the best thing is just to enable it all, right? You're not looking for a production project. You're just looking to have some fun or some learning. In that case, you can just enable them all, like screen space, ambient occlusion, global illumination, reflection, and for example, here, even screen space shadows. Just activate them all, and you can always turn them off later on. So now you added support for ray tracing, for these ray tracing effects. That doesn't mean that you have them already there in your project, right? You need to implement them. Basically, what you need to do is to decide which ray tracing effects you want to start with. And one of the easiest ones, of course, is screen space reflections. In general, most of the effects you need to add through the volumes. Basically, this is a way of telling Unity, I want to add these effects when the player is here. But yeah, just for starting, I suggest you to start with the global volumes. These are volumes that contain a list of effects that are going to be applied all the time in your scene, no matter where you are. You do this by going into the hierarchy and, the typical right click, and you add a global volume like this. And here, what I suggest you to do is to select the profile. You should have one created by default by Unity. Just select the profile that is called default settings volume. This will automatically add some effects to your scene. Now, you have a lot of effects here, but that doesn't mean that you are using ray tracing yet. In fact, you aren't. Okay, these are usually the raster variants of the effects. But we're lucky that Unity made it super easy to switch from raster to ray tracing effects for some of them, right? So for example, for ambient occlusion, you just need to open this tab, the ambient occlusion effect, and then you will see their tick box that says if you want to actually use ray tracing. So I think one of the best ways for me to show you all of this is by going through this video, in which I basically show you how it looks. So this is the environment that I used from a colleague called Jens. He owns a company called Binary Impact. And the only thing I did here, I promise, because I'm a programmer, I just added a few cubes and spheres. That's the only thing I can do as a programmer, okay? So I added these weird things on the left that you can see. And I just added a material to that is highly reflective. I just set it to metallic 1, I think, and smoothness 1 as well. As you can see, this cube is reflecting perfectly the contents of the scene, no matter if it's on the screen or not, which is one of the biggest benefits compared to raster-based reflections, for example. So I'm just going to shut up and play it. Okay, so here's another cube with another reflection, and there should be a few more. And here's another one. And in this case, just to add some variety, I added a sphere as well. You can see it here now in this show. There it is. This is all running in real time. I think it's about 30 FPS, 25 to 30 FPS. But bear in mind that I didn't put any optimization effort on this. And I'm probably doing overkill settings. So like I was telling you, here on the left side, you see the screen space reflection. You can also do this without ray tracing, But in that case, you will not see the reflection of the elements that are off screen. And here's where ray tracing comes in very handy. You see here the checkbox that says ray tracing on preview. If you enable that, then you get the reflections through ray tracing. If you disable that, you get them through raster graphics. So that's all there is to it, really. There's not so much more to do about it. Now, I think I also have another example that I created a month ago or so. And when I say create, I say kind of acquired from the store. Like I said, I can only do cubes and spheres as a programmer. This goes through the process. So that might be also an interesting video to watch. So basically, this is a very flat looking scene. Of course, there's some basic effects added to that, but there is nothing special about it. What I'm going to do right now is to go to the project settings, and I'm going to activate the colored shadows. So first, I select the HDRP medium quality profile, because as you can see on the right, this is the one that I'm using right now as the default one. Once I choose this profile, then I go down to the lighting section. And here I look for the shadow section, and then I activate screen space shadows. Okay. And then I close it. And now, when it comes to shadows, this is not the typical effect that you want to do in the volume. It is some setting that you add per light itself, in this case, directional light. And because of that, you have to select the directional light. And somewhere down below, you'll see a category called shadows. And here you have an option called screen space shadows. So you can activate it, and that will activate the raster mode of screen space shadows. Now, that doesn't look good. In fact, it doesn't look like anything. But if I turn the ray trace shadows on, then you will see that it effectively changes the scene quite a bit. So yeah, this is the kind of color shadows that I was talking about. This is generated in real time. And of course, there's a bit more to this. You also have to create this kind of stained window. You have to set up the material in a way that it adds some transparency and how is it called? The refraction mode to that, right? But it's something that can take you 10 minutes to set up if you follow the documentation. So that's the result that I got from this small experiment.
Can I just add that that's really great? Actually, not every engine that's implemented ray tracing is at that point yet. That's a really impressive aspect of Unity's implementation today.
Yeah, I was also very happy to see that. Actually, I can probably show the project itself. If you have any questions, I'm also fine. This is running in real time. By the way, I learned this trick from Emil. Thanks for that. The always refresh option, that's great to know. Okay, so basically I can just switch and rotate the light around, and you will see that it's totally real time. I don't know the frame rate here, but since I'm also streaming, I don't think that's going to be accurate. And the last thing I wanted to show is the setup on the window material. Here it is. So the only thing I had to do here is to add a base map, okay? And of course, because if it's a window, you also want to reduce the transparency. You don't want to leave it opaque, otherwise it's not going to be very inspiring, a very inspiring view. And then you need to give it a refraction model. I have to correct myself. And that's all that there is to it. I mean, you can add a transmittance color and a few maps to make it prettier. But yeah, it's not much more complicated than that. You can get results very quickly, in my opinion.
All right. Well, thank you so much for that detailed walkthrough of setting up the game scene in Unity. We're getting a couple questions in through the Q&A. I would love to just suggest that if folks have questions, definitely go ahead and use that Q&A feature, and we'll actually walk through it in the Q&A portion of the presentation. A lot of the initial questions are just on hardware setups, on the best version of Unity to use. And we have definitely, the full rundown of that ready for you guys. So the last question actually that I want to pose to the group. So speaking of hardware, that was the hardware request. NVIDIA actually provided our Unity insiders with Titan GPUs. So these are real powerhouse, professional grade GPUs that really, I think, kind of kick the pants off of any minimum spec requirement for building out a ray trace project. It was really exciting for us to be able to offer that to our community. So I'd love to hear, Emil, how do you expect that having this Titan will change your workflow in the future, even on non-ray trace projects? Of course, we have Unity machine learning and other things where the Titan's capabilities are actually going to come into play.
So I guess machine learning is out of my scope at the moment, at least, but it opens up the opportunity for it. So I'm gonna continue with ray tracing and the Titan card in terms of creating graphical demos, both for animated projects. We're already doing one with Unity that's going to launch later this year or early next year. And I'm also gonna try to work with marketing pieces, so more in terms of digital design and the graphical design world. I'm gonna try to make some projects that are going to be really high on reflective stuff and subsurface scattering to really test not just the hardware but also to see Unity progress into that kind of area, which I really want to see them go there.
That's incredible. I'd actually love to hear, like, without breaking any NDAs, do you have any potential use cases you can talk about in terms of where these effects would really shine?
It's not for a client project per se yet, but I have concepts thought up. I know Slack and Intercom and Google as well. They really push into the 3D space as well for web design and digital design, and I think that's really amazing. And fidelity is a really important factor there as well. And that paired with the benefits of real time, like quickly going from one look in a scene to a different one. That's what I want to test out. So I want to take one of the characters from Mixamo and strip them from their different kinds of armor and whatnot. Give them a custom shader that's really reflective, and have them dance around in a room of really bright colored patterns. So that's the basic gist of it.
That sounds really exciting. I hope you get to share it with us when it's ready. So Ruben, same question. We were able to send you one of the Titan GPUs, and now that you've had a chance to play with it a little bit, to walk through it, to build some content, some ray trace content, do you have future plans or anything else you're excited with about this piece of hardware?
Yes, indeed. I will first play a lot of Minecraft. Then later on, I will also do some ray tracing. I think I still have 4 or 5 posts to publish on the ray tracing series on my blog post. And I don't know, for example, machine learning sounds like the typical topic that I wanted to learn for ages, but never had the chance to. So maybe now is the best time for it, I guess. And, some colleagues have also told me to do some Bitcoin mining, but I think I will pass on that. So yeah, I think there's a lot of opportunities for me to use the Titan RTX. That's
great. So, Richard, of course, we're talking here about NVIDIA's boards. So from NVIDIA yourself, what kind of opportunities are open when it comes to the different types of ray tracing enabled hardware available? Like, not everybody is going to get a Titan, but we've definitely had a lot of questions here in the chat about hardware setups and what boards are best for ray tracing and that sort of thing. So is there any insights you can share with us on that?
Oh, sure. Well, the Titan hardware is going to be great generally for high-end development. Typically those cards are like 24 gigs of memory. That's more memory on the GPU than a lot of people have, for their system. So that's pretty powerful. It means that you don't really have to worry about, I'm using 8K textures. Maybe I should scale it down before working with it. You can just kind of go. So that's really powerful from a workflow standpoint. And having, tons of applications open simultaneously, maybe really complicated scenes that are unoptimized, you just sort of put it in there and work. But in real application, most games aren't going to use more than, even a high-end AAA game with ray tracing effects is going to be, it'll reside with like 8 gigs or less of memory, often like 6 gigs or even 4 gigs. So you don't need 24 gigs to run like, the latest game. It's very nice for development. And that's really the purpose of that card. And that's why it has so much memory.
Great. So from the consumer side, we know you guys got the GeForce series, which is, you're playing your ray traced games. And then from the actual creator side, you've got your multiple instances of Unity, maybe throw Max and Maya in there, a couple other things you can run all at the same time on the Titan. So it sounds like that's kind of like the big difference between those options there. So
yeah, I can say, especially from a developer standpoint, like we work a lot with developers of all sizes on optimization tasks. So we're often, because they have a lot of questions, how do because they know people aren't going to have the most expensive card. They'll have maybe a 3070. They'll have maybe something a lot less. They'll have a 1060 or something. So the question is how do we get 60 frames per second on that? How do we get 90 frames per second? And we're often optimizing our software and working with them, to help educate them better. These are your options. This is how you can get there. And there could be a lot of options that developers aren't necessarily aware of, initially, but like after working with them and stepping through it, like, we can help them out. So we're always trying to make sure everybody's games are running as fast as they possibly can using ray tracing hardware. It shouldn't just be a hardware solution, right? Like we need to educate people on how to make their software more optimized.
Great. Yeah. And that's definitely that profiling, optimization. Those are all critical steps for any game developer because of the myriad hardware, not just of creators, but also of all of the gamers out there in the world.
Yeah.
Right? So
I did want to say I've been really reading over Ruben's blog, and I really admire his work in this area because he's not just like sort of emphasized how you can get well optimized scenes constructed. He's broken it down because that's one of the ways, that's really a good way to think of ray tracing is the way he's written it, where you think of it in terms of maybe I'm making a game where I don't do every effect. Maybe I'm focused on shadows or reflections or something key. And, sort of after you learn what's important as a developer and maybe you want to make reflections your number one priority. So sometimes it's just a question of making the right choices for your project. And of course, what he said before about like you just turn it all on and try everything and see how that looks. That's a great way to start. But that's a good education tool. Once you really learn what the different effects are, then maybe with an actual project you can say shadows are important, reflections are important, GI is important, and sort of ignore certain other things or just sort of narrowly focus your project. And that's one way to get good performance out of it. At least until, 5 years from now when we have graphics cards that, can render the scene, 100 times faster than they do today.
Always looking ahead. And I have to actually say that I love Ruben's use of tell us how you're getting that beautiful effect on your Zoom screen there.
Do you mean the slider or which effects?
Sorry, your Zoom video of yourself with your blurred background.
Oh, that's actually a good one. So basically I have a tool called NVIDIA Broadcast. I'm sure Richard knows about that. Which, yes, I think he's also using that. So basically, I got the chance to use this software with the Titan. Basically, it uses, I think, machine learning in order to differentiate between you and the environment. So basically, you have the option to do something like, I don't know, background blur. And let me try that. I can also do background removal and auto frame, which this one is pretty creepy because as I move, I don't like it. But yeah, the function is there. I will stick to the blur.
This is a whole other topic. This is like how artificial intelligence is radically changing what we can do with graphics cards and causing us to rethink what is possible. But yeah, it's this sort of stuff is it's an impressive feature what the hardware can do now.
Yeah, I think that, for a lot of us who've been now living in Zoom environments for, the past 9 months, it's pretty interesting to see how some of these things that normally we're looking at as game developers are crossing over into productivity and all these other worlds that we inhabit. So,
Yeah.
So thank you everybody for all of your incredible insights so far on your ray trace projects, on the ray tracing technology, on Unity. I'd love to start digging into some of the questions here that we have in the chat. Just a reminder for folks, there is a Q&A specific function that really helps us kind of go through all the questions. So I'll just start here at the top. This might be a question for some of our Unity devs that I've been actually secretly slacking on the side to see if I can't get some additional answers. Given that most games that support ray tracing allow enabling, disabling it, is it possible to improve Unity's adaptation to make it easier to switch between the mode within the editor without having to go through a full switch and restart of the editor? And one of these things I thought was specific to switching for DX12, and then that was the only time you needed to do it. So I'm not sure, Ruben, if that's actually something you've got like an answer on the tip of your tongue for, or if that's something I need to go to my devs for.
No, that's correct. Basically, it only requires you to restart because you have to switch from DirectX 11 to 12, and that's for the editor. Once you are there, then you can enable or disable the ray tracing effects in the project settings. That's all there is to it. You can really do this quickly.
Okay, and it looks like from our devs, they mentioned that it's Unity 2020.2 and beyond. This is where that functionality is really set up for. So maybe the attendee who asked that question, if you're using an older version of Unity, you had to go back and forth more often. It's because of that. So just go ahead and update to 2020.2. It's currently in beta right now, so you can just go ahead and get that version, and that's got that functionality. Beginner's question, always love those. Is HDRP suitable for mobile projects? Unity actually has URP, the Universal Render Pipeline, which is kind of our go-to for mobile development. And I think that that's probably, as a beginner, what you're going to want to start with. So hopefully that answers your question. It's a basic question, but could we have the exact hardware details both for Ruben and Emil? So guys, are you willing to share your setups there beyond the Titan GPUs that you've got running?
Yes. So in my case, it's 32 gigabytes of RAM, and it's not super new, the CPU, but it's a Ryzen 2700X. So, and in my experience, the biggest cost from ray tracing came on the GPU. So the CPU, while it matters, it shouldn't be the bottleneck.
I'm actually not able to share the exact details because the computer is located at a different place in Copenhagen at my brother's. His eyes just brightened up as soon as he heard that there was a Titan RTX possible to use for gaming. So he's actually using it for gaming as well. I'm pretty sure it's 16 gigs of RAM, and it's a brand new computer. So, but the exact specs I can share at a later point if necessary.
You're doing development on a virtual machine over the internet, is to another country, another city?
No, just at a different place in the same city.
Okay.
So I'm running on a MacBook Pro, and then it hooks up through a program called Parsec to the stationary computer. That way I'm able to work as a freelancer remotely on a really powerful computer.
Another question, this actually is a good one for Richard. How much difference is there between the Titan and the 3090 for ray trace rendering?
Yeah, that's a good question. Technically, I mean, the 3090 might be more powerful for rendering right now just because it's newer. I say might be. They might be very close to each other. They have the same amount of memory, So it's kind of hard to say. It's a bit of a wash, I think. I mean, they're both very high-end cards that run things very fast, and it's possible one might have certain technical advantages over the other, like in terms of memory bandwidth or some other technical details. But I would think that in general they're in the ballpark of each other.
Great.
I don't. I would also just add I don't know the exact number differences. So it's a good question. I just don't know the precise differences between them.
Well, we've got a great follow-up to that one, which is also going to put you on the spot. Would the Titan in the future start replacing Quadro cards, or do they have a different role?
That I don't know the answer to.
And if you did know, you probably couldn't say.
Yeah, there's that too.
Can I use the Quadro RTX products for Unity ray tracing?
Oh yeah, absolutely. I don't see any reason why not.
When updating a project that was built with the standard lighting in 2019 or 2018, is it easier to start from scratch with basic geometry, or can previous materials and lighting be reliably upgraded to start with HDRP?
Actually, Emil, I think you've ran into some of that in your project. I don't know if you can answer that, but I think that's a conversation that you probably, Shane, would be better off taking to a forum that's dedicated to upgrading your projects. But Emil, if you have anything you can add.
I haven't started a standard project and then upgraded to HDRP, and I guess it totally depends on the exact project and Unity versions as well.
And I also will add, Shane, it depends on the assets that you were using, and if you purchase them from the asset store and if they are being supported and whatnot, or if you're using, custom created assets. So like I said, I think this is a better question to be taken to a forum. And if you'll give us a minute, we'll try to find the exact forum for you to go and ask. So stay tuned.
I can maybe tell my experience with it. I've gone through this.
Super, Ruben. Thank you.
If you remember the scene where I had the color shadows, I bought this asset actually. Yeah, well, I bought this asset and it was not HDRP ready. So I had to convert it and upgrade it to HDRP. It took me more or less 1 day, and 1 day for me, it's about 10 hours, but I'm not an expert. Mostly was due to the changes in the light mapper settings, as far as I can tell. It's a complex scene, so I think 1 day is totally fine. So I will try first to upgrade your materials. Unity has an upgrade button for that, where it upgrades all the materials of your project. Try that. You might need to do a few tweaks. And if you think you will have to spend more, like longer time, tweaking than starting from scratch, then just go start from the scratch. Just try it out, I would say.
Great. Hopefully that answered everybody's question. So then we've got another, it says again, a hardware question for Richard, but then it doesn't actually have that question. So, okay, sorry. So that was from Elliot. I believe the RTX 3000 for laptops are to be released in January. Will they be enough to develop RTX scenes?
Well, I would just say, I don't know about that particular hardware, but I would just say any RTX hardware can absolutely develop RTX scenes. Actually, my experience is similar to Ruben's in that I got started on a 1 series card. I started doing ray tracing on a GTX 1080. And Ruben, you used a 1060, is that right, originally? Or
in a laptop, yeah. I was with the Microsoft Surface Book 2, which is an i7 CPU and 1060. It works.
Right. The minimum spec is anything that's GTX 1060 with 3 gigabytes of memory or higher. So all that stuff can do ray tracing. Yeah, on the older cards, performance isn't going to be that great. I think for my own development, I was getting like 25, maybe 30 frames per second, but I could do ray tracing on that. Of course, laptops are never going to be as good performance-wise as a desktop. It's just not going to happen. But you can get pretty close. You can get, maybe 90% of the way there. So I'm sure any ray tracing hardware on a laptop, provided it's got, a fast disk drive, you want SSD, you want, good amount of memory. As long as you have all that, it should be a good ray tracing development environment.
I do have another question that came in through the chat of Unity offers some APIs for setting up ray tracing structures. Do these calls only work within HDRP, or can they be called from other render pipelines? The answer that I got from that was technically you can call those APIs in any render pipeline. We often test lower level functionality using the built-in render pipeline. It's just not supported and there's no testing, and any bugs you'd file would be feature requests instead. So a lot of that was magic to me. I don't understand this as much. I'm not necessarily a very technical person, so I hope that answered that question. We're just about at time. We've got 2 more questions in the chat. Is there or will there be a way to only use ray tracing for certain render passes? Say if you wanted to precisely render the vision cone of an enemy projected onto the ground. Super complex question, I feel like. Is that one that has a simple answer that we can have in a minute?
Well, I would just say that's probably not the purpose of ray tracing right now. Ray tracing is mainly about rendering what is seen from the player point of view, or like maybe in a cinematic. Using it for that functionality is interesting, but it may not like yield any real benefit, because the current methods for like doing line traces, like from an AI to things that it might be able to see, tend to be pretty accurate already. It's possible that there's additional accuracy that could happen there, but maybe as ray tracing evolves and becomes more prevalent, that sort of thing starts to take over. We're just doing ray tracing for every single thing.
And last thing, you can also try to play with the layer masks, because some effects can target specific layer masks as well. So maybe it helps.
And then very last question, is it possible to render procedural geometry with ray tracing? Say you have geometry stored in a compute buffer and want to issue a render call. For example, using graphics.draw procedural parentheses. What would it take to write a shader that supports this? I've realized I've actually never tried to say something like that out loud before, so apologies for that. Hopefully that made sense to you guys.
Yeah. That's a very technical question. I don't know, Ruben, if you have any experience doing that in Unity. I could just say, I don't know specifically about the Unity side, but I could say in general, it's an interesting question, because ray tracing, when it started, it needed to sort of be aware of all the geometry in memory initially. So it sort of assumes that the scene is present already, or that it's like on disk and will be loaded. Completely dynamic geometry that's generated on the fly. It's just an interesting question. I don't think I have like a clear answer, other than that might be something that's difficult for ray tracing today. But as ray tracing evolves, our interest at NVIDIA is to make sure that it's expansive and covers all aspects and does everything that people want, and that nothing is left sort of out in the cold. We want it to cover everything that it can.
And Richard, I think that also gives us a nice opportunity to say, Carl, if you do end up trying to figure that out, we would love to see the outcome, because anything procedurally generated with ray tracing is just such a, I don't think we've really seen any content around that. I don't think people have approached the topic just yet, but wildly interesting.
Yeah, in theory, it could work. It could work great. But yeah, somebody would need to do it and find out what the issue is.
So please, if you do it, keep us posted. We're curious to see how it works out.
Yeah. And we're always excited to see everybody's ray trace projects, to be honest. Between us and our partnership with NVIDIA, it's been a really exciting opportunity for us to really guide folks that have questions, or support the community in any other ways that we can. It's exciting technology. It's exciting for Unity, and of course, exciting for NVIDIA. So thank you so much, everybody. We're just over time. I really appreciate all the questions. Thank you to our phenomenal speakers, Richard at NVIDIA, Emil, and Ruben, our Unity insiders, and of course, Elena, our amazing technical marketing person that actually helped set up this entire webinar. So I really appreciate it. Thanks, everybody. Have a phenomenal rest of your week, and enjoy the rest of the content at Unite Now.
Thanks.
Thank you, everyone.
Bye.
All right.
Goodbye.